Thank you. Thank you so much. Thank you for having me. It's been a while since I've been last in Data Weekender. I think my last time was actually the first Data Weekender event. So it's my second time on Data Weekender, and I'm happy to be here. It's a great organized event. So this session I'll be delivering today will be on SQL Server multi-tenancy in the real world. Now, multi-tenancy, databases multi-tenancy is a very broad subject. There are potentially lots of different use cases and different ways to implement it. So hopefully in this session, I'll be focusing on what I think is the most common one, most common use case, and perhaps the most, let's say, maximum impact, but lowest effort, and hopefully lowest cost, at least at first. And it will focus specifically on the use case where an organization would have some kind of a monolith application that they would want to basically convert with minimum effort to a multi-tenancy model, so that they could offer it up as basically a software as a service, as opposed to an on-prem installation. So, okay, so, oh, that did work. There we go. Right, so first of all, a few words about me. My name is Eitan Blumin. I'm a senior SQL Server consultant and DBA team leader at Madeira Data Solutions. We are the leading Microsoft data platform consulting company in Israel. On the screen, you can see some of my contact details. I'm active on Twitter, LinkedIn, Facebook. I have a blog, eitanblumin.com, where I periodically publish all kinds of SQL Server related stuff and data platform, Microsoft data platform in general. I also co-host the SQL Server Radio podcast together with Guy Glanzer, who is the CEO of Madeira Data Solutions. You can find us on sqlserverradio.com for the English episodes, or .co.il for the Hebrew episode. We're doing both languages. I'm a Microsoft data platform MVP for about 3 years now. I have a bunch of Azure certifications, which I'm not going to go into. It's not interesting. Anyways, check us out on modernData.com. So that was a shameless, short little plug, and let's dive into our today's topic. So this use case that you're about to see is based on a real-world project that I still am working on, but the critical part that you're seeing in this session was already implemented in our case, and it works great. The people and organizations involved obviously have been censored. You will see a specific implementation that was a good fit for this specific project. However, your own use case may vary to different degrees, right? As I said before, multi-tenancy is a very broad subject. Hopefully, I'll be touching on the most common scenario, which is not as trivial. So let's go ahead. So our example use case for today is for company Y. Why? Because X is already taken nowadays, I'm afraid. So we'll go with Y, I guess. So the use case is like this. They have a sort of legacy monolith on-prem application, which is like an app service and a web app. They all connect to an on-premise SQL Server database. There's also a few SQL agent scheduled jobs that implement business logic and such. And luckily, this is a good starting point. Luckily, both the database and the application, they have source control. So it's at least they got that part covered. So that made things a bit easier for us, although it's not the main focus of this session. So as I said, they wanted to move on to a multi-tenancy model to step away from the need to perform on-premise installations to deliver their product to their customers, right? They want to have simply users register online and get their own product available from the cloud, basically. Okay, so obviously our first task was to select which multi-tenancy model is best fitting for this. So there are different multi-tenancy models available, common design patterns, I guess you could call it that. I am not going to go too deeply into those. There's an official Microsoft document page. You can see the link at the top in Microsoft Learn, in the Microsoft Learn website, where they delve more in detail into the different multi-tenancy models. But what is important to remember is that the difference between these tenancy models is dependent on several measurements or several criteria that will determine which model is the best fit for your use case. And that's the thing that it will be important for you to focus on as someone who considers making this move. Which kind of measures things like scale, how many databases or tenants are we dealing with or expect to deal with? What is the required tenant isolation from between each tenant? What is the cost, the database cost per tenant? What is the complexity of performance monitoring and management, the development complexity, and the operational day-to-day complexity of creating, dropping tenants, monitoring tenants, and the complexity of the development effort needed to basically implement this multi-tenancy model as opposed to a regular monolith on-prem something, right? So what do we go with? Well, I'm going to go with the specific use case, as I said, for company Y. And these are the requirements that I was presented with. So first of all, obviously, we have a legacy on-prem installation. We need to take that and move it into basically a SaaS model in the cloud, right? Instead of a single tenant, we go into a multi-tenant model. And potentially, we need to support a large number of tenants. And at least in their initial pitch meeting, they said that they expect to have thousands of tenants, and that means thousands of databases. And not only that, but the end users that perform registrations, behind the scenes, a tenant would need to be created for such a registration. So basically, there needs to be what we call a fast self-service, right? So the creation itself of a new tenant needs to be something quick, something fast. Also, we need an automated lifecycle of sorts, which is, we could call it also automated churn. For example, let's say a new user is registering, and at first they get like a free trial account, right? And there's like a trial period for this account. And at the end of this period, the account needs to be shut down, needs to be suspended, but the tenant behind the scenes should not necessarily be deleted, because maybe the user would say like, oh no, my trial was expired, but I actually enjoyed the service, so I want to pay money and register a full account, and I don't want to lose all the data that perhaps I gathered till now. So we wouldn't want to delete the tenant immediately. So there's like a grace period, and only at the end of this grace period, when we are certain that the user is not coming back, then we delete the tenant. Also, obviously, account offboarding and would also require the deletion of tenants and so on. Anyways, the point is that needs to be some kind of automation that manages these, like the life cycle of these tenants behind the scenes, asynchronously in the background. In addition to this automation, there's also a different kind of automation, like a business logic automations. We had SQL jobs before. We need to think about how do we implement that for a multi-tenant instance, multi-tenant model, sorry. In addition to that, they also needed cross-tenant queries for their internal BI and insights, that like the vendor itself wanted to know how many tenants they have, what sort of traffic they have, how many users, how much data they collect, and so on. So then there's a need for cross database queries for this purpose, something that could query for all tenants and then aggregate the results. And as any good old organizations tend to B, they also want to have minimal cost and minimal time to delivery. So in essence, they want to have the cake and eat it too, naturally, as organizations tend to be. So there's a few implications to these requirements that we should take into account when selecting the architecture for our multi-tenant system. First of all, the fact that they need a large number of tenants means that we cannot use Azure SQL Managed Instances or Amazon RDS, because those, at least as of today, are limited to 100 databases max. That is an important limitation to consider. So that means that you would have at most 100 tenants per instance, basically. The fast self-service requirement means that we cannot use DAC packs for generating a new tenant, because DAC pack usually takes a while, especially if the database is complicated and has lots of objects. It could take several minutes even. So that's out of the question, because behind the scene, and not behind the scenes, but in truth, we have like a user sitting in front of the screen waiting for the registration to complete. So it's out of the question for this thing to take too long. Backups, depending on the use case, might also be something that we cannot use, because they may also take too long to do, again, depending on the use case. And the fact that we need to have automation, that is also something we need to consider. We need to have automation that is scalable. It needs to be both per tenant, like something that executes per tenant, but also something that can perform operations across all tenants, okay? And that's also true for the BI queries as well. So that removes us from the table, the Azure SQL single databases and Elastic pools, because those have, let's say, too much isolation between different databases. And while it's not impossible, it's very difficult to implement cross-database queries in Azure SQL databases and Elastic pools. Again, not impossible, but especially when you have a lot of tenants and they churn potentially quickly, like lots of new tenants are being registered and unregistered, and you need to maintain this list. It becomes very, very complicated. So it's usually not worth the effort. So taking all of these requirements into considerations, which model do we go with? Drum roll, please. The model that we went with is SQL on VM. Wah, wah, wah. The most boring one. I am sorry to disappoint, but this is the model that we chose based on all the requirements. And it's not necessarily a bad thing, because the need begets the technology. Okay, we had to go this way because of the needs presented by the organization, and there was simply no choice. So we still have scheduled jobs, although now they should find a way to work, across tenants. We still have a SQL instance, although now it's a VM in the cloud and not something that you have to install per customer. And we have multi-tenants with a tenant per database per customer. The main reason why we went to, let's say, a SQL on VM and not something like a managed instance or Amazon RDS is due to the scale, the number of tenants expected. But if that specific point is, debatable, maybe we could start with something smaller, less than 100 tenants. Then Azure SQL Managed Instance or Amazon RDS could also be a good choice for this model, for this use case. The base model, the multi-tenancy model that we used as a base, as like a starting point, is this one called standalone single-tenant app with single-tenant database, which means that we have like an app, like a pairing of an app and a tenant database, and then this pair is duplicated per each tenant. That's the model, the base model. As I said, luckily we have the code base for both the application and the tenant database in source control. That makes things a bit easier for us during development. We also need the catalog database that would be used for managing connections of, let's say, services, applications, and whatnot that require to do something cross tenants, or maybe it is something that doesn't yet know which tenant it needs to connect to. So it connects to the catalog to get a list of the tenants and know, okay, this is the one I need, and this is the connection string, and I'm connecting and whatever. But this is not exactly the model that we went with, because we also had a need to scale our application. I'm going to go into a bit more detail about what do I mean by that in a bit, but basically the optimized model that we went with is this one: multi-tenant app with database per tenant. So it's not just one app per tenant, it's multiple apps, right? Multiple instances of the apps, and they are spread across the multiple tenants. In other words, the system needs to be scalable and balanced. Potentially a single app could serve, let's say, 3, 4, 5 tenants. But if we get more tenants than that, we need to be able to scale our application. So let's say we want to be able to initiate like multiple instances of the application, and they would automatically load balance between them the different tenants, right? So let's say we have, and they need to be the tenants need to be as equally distributed between these application instances as much as possible. And the scaling could be based on workload and as you know, as requirements, based per needs. And the number, as I said, the number of the application instances need to be independent of the number or the scale of the individual tenant databases. So we need to have something like this. Let's say we have two application services instances, and one would have 3 tenants, the other would have 2 tenants, and each would serve their own set of tenants. And let's say if we get new tenants created, then they would automatically balance the load between them, right? So the way that the basic algorithm, right? Okay, that's the trick number 1. I'm going to show you several tricks that we implemented in our use case that maybe you would be able to learn from. So trick number 1, application tenant auto balancing. So what we do is essentially we enumerate the active services. We need to know which application services we have. So we need to log that in some kind of table or something to know which application services are currently active. And if there are no active services, then we delete all the mappings, all the service tenant mappings. We also need to delete all the service tenant mappings for tenants that are no longer active or services that are no longer active. And then for the remaining list, we need to, for each tenant, calculate like a modulo of the number of active services to match a service with one or more tenants, and insert these new mappings or update existing as necessary in some kind of table in the catalog database, right? The one responsible for managing our tenants. Obviously, if the more instances we have, the more service instances we have, the less tenants we have per instance. And anyways, you get the idea. It needs to be scalable. They're using modulo, we calculate like a uniform distribution of tenants across the services, and that works well. Trick number 2. As I said at the beginning, the cost and time to delivery needs to be minimal. How do we do that? So we need to minimize our development effort. Obviously, it's not going to be 0. Okay, that's almost impossible to implement, but it needs to be as minimal as possible. So what we did is like this. We need to implement this part. We need to have the application instance, the service or whatever, to be able to determine, first of all, is it in a multi-tenant mode or not? Because we need the same code base to support both multi-tenancy model and on-prem model, like without multi-tenancy, because the same code needs to be used for also our, let's say, legacy customers that still have their on-prem installations. Those still need to be supported. Okay, so we need the same application to support both scenarios. Okay, so let's say we have some kind of configuration, like in a config file or whatever, that says, am I a multi-tenant model or not? If not, then we run the tenant-specific process or the legacy code just the same way as we did previously. It's the same legacy code that we have, like, just forked or whatever, like open a thread or something, and run that old code. No additional development effort needed. Just give it the connection string, keep running as you did before. However, if there is multi-tenancy enabled, then okay, we do something a bit different. We connect to the catalog database used for managing the tenants. And first of all, okay, if this is my first time, me as an application service, if this is my first time connecting to this catalog, I need to register myself as an active service, right? The catalog needs to be aware of which services are active. And once we have a new service, we need to initiate the rebalancing, the load rebalancing of between services and tenants, okay? So now we redistribute the tenants across the services now that I have a new service onboarded, okay? Or register, whatever. Okay, so I registered, and now I get some kind of ID. I know which service ID I am, and I added some kind of service heartbeat, okay? So that the tenant catalog would be aware of when was the last activity of each service. Based on that, they would know which services are active or not. And then we need to get the list of the map tenants for this service ID for myself. I registered as a service. I got those tenants got redistributed. Now I need to get the tenants specific to me. Great, I have a list of tenants. Now I go for each on this list of tenants and initialize just a thread for each tenant. If it's not already initialized, I need to be aware of that, of which tenants were already initialized and which not. And then I activate the same legacy code as like a thread or a fork or whatever, okay? So now I have multiple threads running the same legacy code, each one working with a different tenant, okay? Great. And now the service sleeps for some time and repeats the cycle, okay? I again connect to the catalog, see if I'm not registered already, then I need to register. I update my heartbeat, I am active, and then I get again the list of map tenants just to make sure that whether something was changed or not. Maybe a tenant was removed, maybe it was added, maybe a new service was onboarded or removed, and then the list of tenants was the tenant mappings were rebalanced, and I repeat the cycle. And obviously, I also need to be able to manage already active threads by need to stop or kill those threads if I as a service was demapped from this tenant. Okay, if this tenant is is no longer in my list of mapped tenants. Okay, so by keeping the core application engine single tenant specific, which is the red part on the screen, we can keep most of our legacy code unchanged. And our only development effort is this multi-tenancy wrapper layer, all the blue colored parts, which is minimal relative to rebuilding from scratch our entire application. The effort here is very minimal. Okay, trick number 3, fast self-service tenant creation. Now, as I said, DAC packs are out of the question, takes too long. Backups might also take too long, and it's also not supported on every platform. For example, it's not too supported in Azure SQL Managed Instance, and RDS has a few issues with it. Not impossible, but depending on the use case. But this is a trick that I want to be familiar with. DBCC clone database, who knows? Who ever heard about this command? Yes? No? It's a little known command. DBCC clone database. What it does is basically clone a database, but it's not exactly cloning as in it doesn't include the data, the content of the database, but it only clones basically everything else, like the structure, the objects, the store procedures, the permissions. It even clones the statistics if you want, although that's relevant for our use case. But it clones everything in a database except the data. It's a bit different to how like the model database in SQL Server works. You know, there's a model database, system database, based on which each new database is created. So it works very similar. So like it's cloned, right? Although I think in the model database in SQL Server, the data is also cloned. Regardless, just so that you would know this command, it's very useful. It's very, very super fast. It's super fast to clone a database. No need for DAC packs or anything like that. It works very quickly. Although you need to remember that when it is created by default, it is set to read only. So you need to remember to set it to read write, right? The new clone database needs to be set to read write. And because it's not being cloned with the data, we need to now run something that populates the data, the initial static data, for example. Let's say we have dimension, static lookup tables, configuration tables, or whatnot in our model, in our tenant model. So we need to copy the data from those to the new tenant. So we need to have some kind of store procedure, some kind of process that does like a for each of these tables and copies the data. And this process, at least in our use case, it was super fast. We have the tenant model, which is like same idea as the model system database in SQL Server, just sits there waiting to be cloned. It is cloned using DBC clone database, set to read write, throw in a few, copy the static data, and that's it. Takes something like 2 seconds, 2 to 5 seconds, something like that, super fast. Okay, right. So a user registers, runs clone database, a new tenant is created from the model, and then the data is copied from that model to the new tenant. And as I said, this takes like 2 seconds. Okay, trick number 4, change automation. What if we have versioning for development? The development still goes on, right? And now as I said, we have the database in source control as an SSDT project. That's great. But now we have multiple databases that we need to maintain, right? So we have like a source control for the catalog and for the tenant model, right? 2 projects. And we need to be able to update versions. Now, here we have to do DAC packs, right? In order to deploy this version, because our tenants are already active. Obviously, we cannot restore from backups. Obviously, we cannot use DBC clone database because we need the existing data in the tenants to be not unaffected. So basically, we need something like a DAC pack deployment, right? What I recommend is to use DBA tools for DAC pack deployments. They have a command that called publish DBA DAC package. Very easy to use, very easy to use. And the idea would be that we would have some kind of PowerShell script used for the deployment, the change automation, which would first of all publish the catalog if something was changed or it doesn't exist yet, or there's a new version, and it was published. Great, then publish the tenant model, so that we have the model up to date. And then we run a query to get the list of active tenants from the catalog and do like a basically publish for each, right? For each of those, publish the tenant model. Now, the customer requested that, said that in some cases, they don't necessarily want all tenants to have their version updated for various reasons. But it was difficult for them to determine like Based on what criteria? Based on what? They don't know. Okay, I said, no worries, that's fine. Let's just add a column, like a Boolean column, like a bit column to the tenants table, where it says whether the tenant is version locked or not. Okay, and this PowerShell script would when it gets the list of tenants to publish to update, it would only take those where the version is not locked. Okay, where version locked is equals 0. And so that those tenants, the specific tenants that were locked, they would not have their version updated. Okay, and so and then whatever need they have, this vendor that I'm talking about, whatever need they have in the future, where they said, look, I want to deploy a version, but I don't want this, and this tenant to be updated, or don't update all tenants that were created before, I don't know, 2022, whatever. Whatever it is, I don't know, I don't care. Just run a command, update TBL tenant, set version locked, where whatever it is you want, okay? So just lock those tenants, and then after that, publish the, run the PowerShell script, right? So it's very flexible, very easy to use. Now, this process is also possible to integrate with something like Azure DevOps, CI/CD, like a release pipeline to be automated based on the CI/CD cycle. But it's important that the development here will be deployment aware, right? The database development here needs to be deployment aware to allow for zero downtime deployment, basically. And there's all kinds of things having to do with that. At the bottom of the screen, you can see a link to a series of sessions that I have on the topic of CI/CD with SSDT. Some of those sessions also touch upon zero downtime database deployments. There's also a famous presentation by Alex Yates. He's an expert on this field about zero downtime database deployments. So I strongly recommend that you look into that before going wild with your deployments. Okay, last trick, I swear. Multi-tenant job execution. So if you recall, we have business logic jobs for each of our tenants, but now we have an instance. What do we do? What do we create a job per tenant or something like that? So I don't know. I don't have like a perfect answer for that. What we did is that we created the equivalent of each store procedure being executed by a SQL job inside the catalog, okay? Instead of inside the tenant. I mean, it's in both, but the job is running the same store procedure, but in the catalog. And the catalog, since we have cross-database queries and such, the catalog is able to, instead of just run the procedure as is, run it for each tenant, right? There's like a cursor or something, and execute the same store procedure, but for each active tenant. Now, obviously, this has a few implications. First of all, it's data-driven, okay? So it's very flexible. It executes only for the relevant tenants that it needs. You just set this job up once, and the store procedures do the rest of the work. And you don't need to configure it, don't need to maintain and configure it per tenant. The catalog does everything. But it also means that it's serial, sorry. Because there's like a for each loop, right? So depending on the process at hand, it may take a long time, right? If we have a lot of tenants that it executes the same store procedure for each, it may take a long time. So it may be worthy to consider other methods, although those would have to be outside of SQL Server. And I'm talking about things like Azure Automation or Data Factory, Azure Functions, or other similar orchestration tools where the basic idea would be the same, right? But it wouldn't be implemented in T-SQL. So, but the basic idea is the same, as in connect to the catalog, get list of active tenants, for each do something. that's the basic idea, right? And how do you implement this for each thing? That depends on you and your needs and the technology you're using, right? There are all kinds of orchestration tools out there, but the important thing to remember that it must be data driven. Okay, the catalog has to be the thing that determines which tenants need to have this thing executed. So this is our final result. How am I on time? Oh, good, nice. I'm good on time. Impressive.
You're very good on time. Don't worry about that one.
That's impressive. I wasn't expecting to be so good on time. That's good. Okay. So this is the basic overall architecture that we have. We have multiple application services, automatically load balancing the catalogs, the tenants between them using the catalog. We have data-driven automation, execute again based on the catalog, executing whatever they need to execute per tenant. Where's my mouse? There we go. Okay, so I was talking about this app service, and then we have the automation, the tenants. Every time there's a new tenant registration, it duplicates the model, the tenant model, into a new tenant, and then does whatever. And we have the database in source control as an SSDT project, and we have data-driven change automation to deploy these new versions, again, using the catalog to get the list of tenants. This works, okay? Again, to remind you, I'm talking about a real-world project that I was involved in to implement this thing. It took to implement about half a year, which is nothing. It's microscopic in terms of organizational development. It was very, very quick to get to this phase, okay? So I personally am very proud of it. I'm glad we were able to deliver on this. Final thoughts and a few tips for me. First of all, you need to focus on data-driven logic. This catalog database would be used for managing and maintaining the list of active tenants and whatever it is you need to do with tenants as tenants. In terms of, and all of these things need to be data-driven. The operationals, whatever operational day-to-day operation processes, the maintenance, the management of tenants, automations per tenant, all of these have to be data-driven using the catalog. Don't forget security. Okay, if you have that depends on whatever it is that you have implemented, how your specific application works and how it connects. You need to take into consideration the isolation between tenants. You need to take into consideration, let's say, for example, sorry. Let me go back to this one. Yeah, this is what I was looking for. For example, we have basically two types of processes here, right? We have the legacy process, and we have the whatever it is multi-tenancy wrapper process. Okay, so this blue multi-tenancy wrapper process needs to be able to connect to the catalog. Okay, and it needs to be able to connect only to the catalog. Only to the catalog. So that's like one set of credentials that has access only to the catalog. And then we need to have something that connects into a specific tenant, potentially, if you want to, be as secure as possible. Potentially, this would be a different connection string and a different user, maybe per tenant. Sorry. So that once the app is connected into a specific tenant, it wouldn't be possible for it to do something that is cross database, that goes outside of the bounds of the specific tenant database that it's in. Okay, so that's in terms of security. Oops, sorry, went too far. Apologize. Okay. So the design, as I said, may vary for a specific use case. And the keyword here, the key phrase is the need. The business need begets the technology, okay? You need to choose the technology, the architecture based on the organization needs, but sometimes the need is difficult to identify in advance. For example, for this specific organization, they expected to have thousands of tenants. In truth, it takes a while. Okay, maybe even years to get to that number of tenants. So they decided in the later phase that, you know what, we don't actually want a virtual machine. We want to go to like something like RDS or whatever. And it requires some changes, not too big, but it requires some changes. But this is an example, right? Because they thought they knew to identify the need. Sometimes it's not always necessarily true. You need to remember that and take that into consideration. And stay flexible, right? Be able to do your development as modular as possible, so that it'd be easier to change in the future. Now, in GitHub, I have already an example project for you to use. If you want to see how, this specific use case that you saw in this session, how it was implemented, I threw in the necessary, the critical points, the critical components into the project, so you would see how exactly, in terms of code, it was implemented. And you can check out also additional resources. Obviously, there's the article on Microsoft Learn about the different multi-tenancy design patterns. There's also an old, a bit, not too old, but a bit old blog post series by Erwin Stahl from around 2020, 21, focused on implementing multi-tenancy with Azure SQL Database and Entity Framework. But as of today, I think it's not completed. The series, it's planned to be a series, but as of today, it's not completed yet. I don't know, maybe it was abandoned, but the posts that he did published are interesting and very useful. So I recommend checking that out as well. My series, the webinar series, sorry, CI and CD with SSDT, you can check that out on my website. There's also an interesting open source project for you to check called Dynamic Filters, which is used for basically dynamically executing store procedures with dynamic set of parameters, which is something that might be relevant, for example, for business logic automation per tenant. Okay. And that's about it. So now, first of all, thank you for having me. Thank you for being here.